Hey, this is Math 8, Unit 5, end of unit review. So here we go. Hopefully you've worked this out already. So if you're just coming here to check out the answers, that's not going to help you in your test in a couple of days. So do the work, then use this to check your work and see how you did, okay? So first of all, if you know the volume of a certain cylinder can be found using volume equals 49 pi h, what is the radius? So a cylinder, if you recall, looks like something like this, right? And a formula for a volume of a cylinder is volume equals pi times the radius squared. So it's the area of the base times the height. Now in this case here, they provided us with this information. They said that we knew that it was 49 pi times h. So there's a pi, we've got a pi there, we have an h there, and we have this number 49. So 49 is what they're saying is the value of r squared. So r squared equals 49. So what two numbers can you multiply together to get 49? We would say that r would equal 7. Because why? 7 times 7 is 49. So this cylinder must have a radius of 7. In this case here, we don't know. Just 7. Okay. All right, number 2. If you know the volume of a certain cone can be found using volume equals 75 pi h, looking at a cone here, what's the radius? So a cone, recall, is 1/3. The volume of a cone is 1/3 of the volume of a cylinder, pi r squared h. So in this case, again, they've given us 75 pi h, pi and h. So the pi's go together, the h go together, which means that 1/3 goes with 75, and so does the r squared. So what we can do is we can set them equal to each other and say that 1/3 times r squared, those two together combine to equal 75. So let's multiply both sides by 3, so that r squared equals 75 times 3, which is 225. Now, I'm not great with my math facts, but I know that 12 times 12 is 144. So I'm looking for a number bigger than 12 to get me there. And because it ends in a 5, that kind of narrows it down and say, well, let's start with 15. And what do we find? 15 times 15 is equal to 225. So in this case here, we would say that r, the radius of the cone that has that volume, is actually 15. Number 3. For cones with a radius of 9 units, so we're talking about cones with a radius of 9 units, the equation volume equals 27 pi h relates to the height of the cone in units and volume of the cone in cubic units. Use this equation to complete the table. Okay, and express this volume in decimal form, round to the nearest tenth. Okay, so we know that information is given to us. Volume equals 27 times pi times h. So that's going to be the 1/3 times the radius squared. This is 27. So 27 comes from the 1/3 radius squared. And we know the radius is 9. And so 9 squared is 81. And the third of 81 is 27. Right? So that's how you got to 27. So that doesn't change. What's going to change here is the volume of the height. And we're going to round everything to the nearest tenth, which means we're going to probably need to use, we can use either a calculator for pi or 3.14. I went ahead and calculated mine with just using the pi feature on my calculator. Again, you might get a little different answer depending if you use pi or if you use 3.14. In other problems in the packet, they tell you to use 3.14, so I was guessing I'm supposed to just use pi. So, in number 1, for the height of 1, we would do 27 times pi times 1, and when you calculate that out, you end up with 84.823. And the nearest tenth, this is our tenth, so we look next door and it's lower than 5, so we're just going to chop it off right there and say 84.8. When the height is 3, we'll do 27 times pi times 3. And when you multiply that out, 27 times pi times 3 is actually 254.46. I have the tenth is there, so I look next door, it's greater than 5, so I'm going to round everything up. So that's going to become 254 and what's 1 more than 4? 5. For 6, we do 27 times pi times 6. We multiply that out, and you're going to get a solution there. I'm going to let you do that one on your own. And for this one, we're going to say that 27 times pi times the height is equal to, and they give us a volume, 339.1, which again is pretty close, but it may not be accurate because of what the value of pi is. So to solve this here, the thing you might want to do first of all is recognize that to do this here, you're going to do 27 times pi, or you could divide first. You do 27 times pi, and when you do 27 times pi, what I come up with is about 84.823 h equals 339.1. So now if I divide both sides by 84.823, what I come out with in this case here is, I'll check it one more time, double check, 339.1 divided by 84.823, come up with 3.9977, it goes on, for the value of h. So h is equal to something like that. Now, probably, it's not actually 3.99. I probably could estimate that h is probably equal to 4, because that's probably a better approximation for what that is going to be. Okay, now it says to go ahead and sketch that on the axes right here. So we have, when the height is 1, the volume's 84, so about there. When the height is 3, the volume is 254, so about there. When the height is 6, I skipped that one for now. And when the height was 4, we said it was 339, so somewhere about here. So now if you use your straight edge, your ruler, and you draw that out there from 0, you can create a nice line connecting all those dots up. That looks something like this. So as you're working on what the volume was for 6, you could estimate it's going to be somewhere right about here. So it looks like it's a little bit more than 500. So if your answer was about 500 or a little more than that, you probably got that right. Part C says, is this a linear relationship between the height and volume? Explain why or why not. We would probably say, yes, it's linear. It sure does look like it's a line, and it follows a consistent pattern there, right? It goes through the axes. It's a straight line with very specific points, so we would say, yes, it's a linear relationship, and we would stop there with that one. Okay, let's look at the next page. Number 4. So it says the dimensions of a soup can are shown. Find the volume of the soup and round your answer to the nearest cubic inch. Okay, so a few things we want to take a look at here. First of all, it gives us the diameter, not the radius. The radius is going to be half of the diameter, so the radius is going to be 1.5. Now the volume for a soup can is a cylinder, so we can do pi times the radius squared times the height. And in our case here, we have pi, we have a radius of 1.5 squared, and we have a height of 4.5. So, to figure this out here, we're going to go ahead and do 1.5 times 1.5 to find out what this is. So we end up with pi times 2.25 times 4.5. So that's, one way of looking at it. So when I use the calculator here, I would do pi times 2.25 times 4.5, and I end up with 31.80 and so on. Now I'm going to do it to the nearest cubic inch, so I look at the inches being here. This is greater than 5, so I'm going to round everything up. So that becomes 32 inches cubed is what I have for that volume right there. The key thing here was recognizing that they gave you a diameter, not the radius, so be very careful about that. Number 5. A cylinder, once again, has a volume of 9 pi. What's the volume of a cone with the same radius? Remember, the cylinder is like this, and a cone is like this, and this is pi r squared h, and this is 1/3 pi r squared h. So if this value is 9, pi r squared h is located right there, so we could actually put the 9 in that place right there, and we'd have 9 times 1/3. So a cone with the same radius and height is going to be 1/3 of the cylinder. And 1/3 times 9 is equal to 3. And we would say 3 pi inches cubed. Keep the pi with it because the pi is still a part of it. All right, so there's that one. Number 6. This Billy uses a large paper cone as shown to hold popcorn. How much popcorn can the container hold? We're going to use pi as 3.14 and round to the nearest hundredth. So again, we have a diameter. I want to make sure I use the radius because the volume of a cone is 1/3 pi radius squared times the height. So I have a 1/3. Pi is 3.14. The radius is half of 12, which is going to be what? 6 squared. And the height is here at 22. So I have 1/3 times 3.14. 6 squared is 36 times 22. And we're going to multiply all of that out. So again, you could do the multiplication part first. 3.14 times 36 times 22 equals that crazy number. And let's divide it by 3 because that's what multiplying by 1/3 is. And I end up with 828.96. And my nearest hundredth, I'm already there, so I can just write centimeters cubed for the solution for that one. Then it says that Chai uses a cylinder with the same diameter. So it's a cylinder with the same diameter and height for his popcorn. How much more popcorn does the container hold? Okay, so the popcorn, because it's a cylinder, to go from a cone to a cylinder exactly the same is multiplying it by 3. So if I take 828.96 and I multiply that by 3, I'll have the volume of the cylinder, which in this case is 18 carry the 1, 27 plus 1 is 28, 24 plus 2 is 26, 3 times 2 is 6, plus 2 is 8, and 3 times 8 is 24, 2 behind the decimal, 2 behind the decimal, and there I am. So that's the volume of the cone. The question is how much more? So we'll do 2486.88 minus 828.96. So when we work that out there, 2486.8 minus 828.96, we come up with 1657.84, and these were centimeters cubed. So it's that much more. And that's the key thing there. You might have figured that part out and said, hey, I got the volume right for that. It's 3 times. That's great. The volume is definitely that. But the question was, how much more popcorn does the container hold? So you have to find the difference between your answer here and answer here. Now, if you got that answer wrong, then that answer is not going to be the same as mine as well. So be very, very careful about that. Okay, let's look at number 7. For number 7, it tells us that cones A and B both have a volume of 64 pi cubic units, but have different dimensions. Cone A has a radius of 8 and a height of 3. Draw a picture of cone A and label it. So we have a cone. We have a radius of 8, so we can put an 8 right here. And we have a height, which we can draw down the side if you want, up to you, of 3 units. Okay? So that's what we have. Show the work to support that it actually is 64. Well, if a cone, it's going to be 1/3 times pi times the radius, 8 squared, times the height, to find what that's going to be. So this becomes 1/3 times pi times 64 times 3. 1/3 times 3 is 1. So you're left with simply 64 pi. So that's how we got that solution right there. The next part, C, is a little more complicated. It says find a possible radius and height for cone B so that it also has a volume of 64 pi units. Okay, so we're looking for different dimensions. So what that means is if I take a look at my formula for volume equals 1/3 pi r squared h, I know that my r squared h has to then equal, all this needs to equal 64 pi, because that's what I have so far. So my 1/3 times pi, r squared h, has to equal 64 pi. Now the pi's are on both sides, so I don't have to worry about that. I could then multiply both sides by 3 times times 3, so I can eliminate the third. 64 times 3 is 192 equals r squared times h. So now I'm looking for two variables. Okay, it's a little bit of a guessing game here. I need a variable that I can square and then multiply by a different variable to get 192. All right, so before, we had in our thing we had 8, and 8 got me up pretty good. 8 got me up to 64 pi, but I didn't have a height because it kind of went away there. So let's think about this. I got to get a radius that's going to get me to 192 times there. So I think about a couple things. If I did a radius of 6, I would do 6 times 6, which is 36, and then I have to think to myself, okay, if I divide that, if I have 192 equals 36 times an h, what would my value of the h be? And 192 divided by 36 gave me 5.33, a crazy number. So could I use that? Yeah, I guess so, but this is going to be a weird volume, or weird height. So yeah, you could, but I didn't like that one very much. So I tried another one. I tried 4 times 4, which was 16. And then when I did 192 equals 16 times the height, again using this right there, and divided both sides by 16, I found out that 192 divided by 16 is actually equal to 12. And so I got a value of 12 for the height. So if the radius was 4 and the height was 12, I seem to also be able to get this 64 value there as well. So just something to think about. Could you find other numbers? You probably could. That's what I did. I just did some guess and check. All right, number 8. There are many cylinders with a height of 12 inches. Let R represent the radius in inches and V the volume. Draw a cylinder, label the height 12 and the radius R. So cylinder, here's our cylinder, looks great. And our height is going to be 12 inches, and our radius is here, and we put an R there. I could put it on the bottom too, doesn't matter. Now volume equals pi r squared and then times 12 because of our height. Complete the table with the given radius with a height of 12 inches for the cylinders. So we're going to plug this one right into there. So the first one, we do pi times 1 squared, which is 1, times 12. And we're leaving it in terms of pi, so this becomes simply 12 pi. For 2, it's pi times 2 squared times 12. 2 squared is 4, 4 times 12 is 48, and we keep the pi. Here we have pi times 3 squared times 12. 3 squared is 9, and 9 times 12 is 108 pi. Okay? Do the same thing for 4, and the same thing for 5, and complete the rest of that table. I'll let you do that one on your own then. The next thing says, is there a linear relationship between the radius and volume? Looking for a linear relationship, a line. Well, if you were to just graph this real quick and said I had a 1, a 2, a 3, a 4, and a 5. And I had over here, let's count up by, I'm going to 100 already, so let's go 25, 50, 75, 100. Okay, and that's just with 4 values. You're going to have more because you did 2 more. When the height was, radius was 1, sorry, the volume was about here. When there was 2, we were about here, and 3, we were about here. So it's hard to tell here on this line the way this works because I only have 3 values. When you continue with 4, 4 is going to be up here, and 5 would be up here. So you're actually going to end up with something that looks a little bit more like this. It's not, oops, sorry about that. It's not going to be a straight line. And the reason for that is we are looking at the radius squared. When we square a value, it's growing exponentially. Exponentially. So it's going to be more of a curve there. It's not linear because of the squaring that's happening there. So we would say it's not linear, and that's all we would do for that one. All right, let's take a look at the next page. Okay, so number 9, it says a shot put is a sphere-shaped metal ball with a diameter of 4.2. So it is a sphere-shaped metal ball the diameter of that. What is the volume of the shot put to the nearest cubic inch? And use 3.14 for pi. So to do this, we need to make sure we know what the formula for this for a sphere is, which is 4/3 pi times the radius cubed. Okay, now a couple key things here. They gave us a diameter, not a radius. So if the diameter is 4.2, the radius is going to be half of that. So radius half of 4.2 is 2.1. So now we're going to use that value. We'll have 4/3 times pi, which is 3.14, times 2.1 cubed. Now I'm going to do 4/3 here, keep the 3.14, and 2.1 cubed is going to be 9.261. And now we'd multiply this out. You can multiply these together, okay, and that's just fine to do. When you multiply those together, you have 3.14 times 9.261, and that's going to be 29.07954. And we're going to multiply that by 4 and then divide it by 3. So I take that number, my answer, I multiply it by, back up there, by 4, and I get that number, and now I divide that by 3, and then I end up with 38.77272. And I want the nearest cubic inch, so I look here, I want to go look at that number then. That's greater than 5, so I'm going to round up. So it becomes 39 inches cubed. And that's number 9. For number 10, so the cylinder has a radius of 1.4 centimeters. Its volume is 83 cubic centimeters. Find its height. Okay, so our formula is the volume equals pi r squared h. They gave us the volume as 83. We have pi, which we're not sure if we want to use 3.14 or not, but let's go ahead and use 3.14 for now. We know a radius is 1.4 squared, and we don't know the height. So now we need to use all this, figure that part out, the computation, to solve for h. Alright, so 83 is still equal to 3.14. 1.4 squared. Well, 1.4 times 1.4 equals 1.96. Times the height. When you multiply those together, you have 83 equals, and you can estimate here, really, right? This is 3 and 2, should get something close to 6, and sure enough, you get 6.1544 times the height. So now we'll divide both sides by 6.1544. So when you do 83 divided by 6.1544, we end up with 13.48 as the height. And because we want to the nearest tenth, here's a tenth, we look next door, that's greater than 5, so we're going to round everything up, and we have 13.5 for the height, and this is centimeters. Alright, and that's number 10. For number 11, we have a composite figure. We have a cone on the top, and we have a cylinder on the bottom. So we have to do two equations here. Now for both of them, it says the diameter is 2. We want to know the radius, which will be, diameter is 4, so the radius is 2, which makes this radius also 2. So for the cone is going to be 1/3 times pi r squared h, so that's 1/3 times 3.14 times the radius, which is 2 squared, times the height, which is 4.5. That's the cone part. And now for the cylinder, we're going to do pi r squared h, okay, and that's going to be, in this case here, 3.14. Radius is 2 squared, and the height is 10. So now we have two equations or computations to work out there. And so when you do the math on this one, so make sure you show your work to your teacher. This one works down to be a total of 10.84, and this one works out to be a total of 125.6. You're going to want to show your work for that. Now because it's composite, I want to join those two things together. So I'll take 125.6 and add to that 10.84. So that becomes a 4, 14, decimal stays there, 6, 3, and 1. So I have 136.44 inches. I want the nearest tenth, so that's my 10th place. So this number is less than 5, so I can just chop that off. I have 136.4, and this is going to be inches cubed. Number 12. It says Fresno State has an observatory on campus for students to view the stars at night. The height of the building is 16 feet. There's that. The radius is 10 feet. Okay, so it's like a cylinder, but we have a half of a sphere on the top. Call that a hemisphere. But we have half of a sphere there, and we have a cylinder on the bottom. Those are our two composite shapes. We're going to use pi as 3.14 and find the volume of the whole thing. So the sphere, the calculation for sphere is 4/3 pi radius cubed. But we want half of that, so we can multiply the whole thing by half. And for the cylinder, it's pi r squared h. So let's do this together here. This would be 1/2 times 4/3 times pi, 3.14, times the radius, which is 10 cubed. All right, so 10 cubed is 1,000. So we really have 46 times 3.14 times 1,000, and that's going to add up to be, or multiply together, to be 2,093.3. In this case here, we're looking at feet cubed, cubic feet. For the cylinder, we do 3.14 multiplied by the same radius, 10 squared, times the height, which is 16. So that becomes 160 times pi, which works out to be 5,024 feet cubed. Combine those together, we have 2093.3, 5024.0, we have 3.77, we have an 11, and we have a 7. So 7117.3 feet cubed for the combined volume of that shape right there. All right, moving on to our very last page, rounding practice here. Okay, gonna practice some rounding. Here we go. Julio is solving for the volume of a cone with a radius 10 inches, height of 20.5. His work is shown here. Directions say to use 3.14 for pi and round to the nearest tenth. Okay, his answer is currently in terms of pi. Awesome. So finish solving for volume and round to the nearest tenth. So if you finish solving for volume and round to the nearest tenth, then I'm not sure actually if they want you to keep it in terms of pi. I don't think so. Oh no, we don't. We want to use 3.14. So we're going to take the 68.333 and we're going to multiply it by 3.14. Right? That's the goal there. When you do that, we end up with 214.56562, at least on my calculator. Now to find the nearest tenth, this is our tenth right there, we look next door, which is going to be the 6 there. Okay, which means I can kind of ignore these numbers, they don't matter. Now 6 is greater than 5, or greater than 4, it's 5 and up, so we're going to round up, which means this number gets to increase by 1. So we have 214.6. Okay, that becomes our answer there. And in terms of units, because we're talking about a cone with inches, we're going to use inches, and this is going to be inches cubed. So up here you can write inches cubed, and that's the idea for that one right there. Okay, number 14 is really the same exact idea, right? They give you the volume here. We want to change the pi for 3.14. We're going to run this time to the nearest hundredth. So whatever your number is, you want to look at, draw a line underneath the hundredth. Let's say it was, this is pretend it was 2.1406. Okay, we would put a line under the hundredth place, and the hundredth place here would tell us look next door, which is there. It's less than 5, so we would just chop it off and say it's that. If it was let's go with 2.407, we would again look at the hundredths place, look next door, That's greater than 5, so we're going to round everything up 1. So the 0 becomes a 1. Again, these are not answers at all. We're just talking about the rounding part, because you're going to multiply that, get a number, and solve it, and then figure out what units you would use for this one there. And finally, the last one, 15. It says in this case here, Ashanti is solving for the volume of the cylinder with a diameter 5 inches and a height 3.2. Here's her work. Volume equals pi times radius squared height. And we can see she has pi. Her radius, she said 5, and her height, she says 3.2. Directions say to use 3.14, so we'll do that right there in a little bit. That's no problem. Her answer is currently written in terms of pi. Great. She made a small mistake. So you want to circle the error and then correct her calculations. So look up here and decide what did she make an error with. Use the question here to see which information did she use the wrong way, and then correct that. When you're done, round it to the nearest cubic inch, and then use the correct units as well for that one. I'll let you do that one as well on your own because it's not too bad. That's it. Hope that helps you a little bit. Get ready for your test coming up next week. Do a good job and let me know how you did.